I was recently approached by IceWhale Tech, which is the maker of the ZimaBoard, to take a look at the ZimaBoard 832. The 832 is their flagship ZimaBoard model, which includes 8 gigabytes of RAM and the faster option of the CPU, which is the Intel N3450. Most of the other specs, I think, are common between the different models. The ZimaBoard is basically like a fanless mini PC with two 1 gigabit Ethernet ports. And the thing that makes the ZimaBoard the most distinctive is the fact that it has a PCIe 2.0 by 4 slot on the side of it. So basically you can expand the capabilities of the ZimaBoard by plugging a full-size PCIe card in the side of it, and you can use it for different purposes. If you want to make a NAS out of it, or if you want like faster networking, so if you want 2.5 gigabits, you can plug a 2.5 gig PCIe card in it. The ZimaBoard also has some SATA ports that are exposed as well on the outside of the box, which is kind of interesting. So you have some options there to be able to expand the connectivity of the mini PC without even opening up, because you don't have to open anything up. It's all on the outside of it. So it's kind of interesting that they took that approach. They made all the interfaces exterior. So I actually have the ZimaBoard here in front of me. So let's go ahead and open it up and see what you get inside. First of all, you get this nice little welcome letter from the company, giving you thanks for purchasing this product. And they give you some pretty cool little home lab stickers, which is pretty neat, because this device is catered towards the home lab community, in case you haven't figured that out already. So they actually give you some nice little vinyl stickers, actually, that you can put on wherever, server rack, whatever, your computer, whatever you want to do, right? So, okay. Next up is, let's do the power brick first. We'll do the most exciting part last. All right. So here's the power supply. And it looks like it comes with adapters, so you can use it in different parts of the world, which is pretty cool. So you can swap it out for different connectors. So it looks like in the bottom of this box, there's actually a SATA cable inside. It says right here. So it's underneath this cardboard, this flap here. So make sure you don't throw that away, because that'll be useful if you want to use a SATA like SSD. I almost threw this cable away possibly. So it has, the power and data here. All right. Now for the ZimaBoard itself, you can see how tiny it is in my hands, right? So this tiny little box houses the ZimaBoard. So let me rip off the plastic here. You know it's brand new when I'm ripping the plastic off, right? All right. Has looks like two little tabs here to kind of open the box. It's kind of fancy. So if you don't want to rip the box, you just got to push those tabs in, like so. Pull it up, and look at this. The box kind of opens up like it's kind of like it's kind of like a transformer or something. Look at this box. Pretty cool. Pretty cool little packaging there. Now we have another cardboard box. So I had the outside box, and then I had outside cardboard box, and now I got another box with the ZimaBoard inside. So let's open it up. Comes with a little user manual to show you some tips and stuff, I guess, how to get set up. And it's in another package. So basically this is good to have electrostatic bag so you don't fry the circuits and stuff, I guess. All right. So, here we go. I'm going to take it out. Look at this. So, you can see the two LAN ports, and you got two USB 3.0 ports. So, this is a display port to connect to the screen, and you got a power barrel jack right here. And on the back, you can see you have two SATA ports. And on this side is where you get your PCIe 2.0 by 4 slot. One thing that's interesting about this PCIe slot is if you zoom in here, you'll notice that it's actually cut open here. It's actually not a solid piece, which means even though this is a by 4 PCIe by 4 lanes, you can actually connect cards that have more lanes in it, and it'll just run slower. So that's actually kind of interesting, because the way PCI Express is, you can actually put cards that are by 8 or 16 in a slot that has fewer lanes. You just end up getting less performance. So as an example, I'm going to try this out. This is the fun thing about a device like this. You can try out interesting configurations like this. So I have an SFP 10 gig card here, as you can see. And notice that the card hangs over past the slot, because it's actually a by 8, has 8 lanes, PCIe. So I'm actually sticking it in a by 4 slot. I thought about getting a PCIe by 4 to 16 adapter, because that's another option, but since that's cut open, I don't have to do that. All of the ZimaBoards come equipped with 32 gigabytes of eMMC storage. So if your operating system, you don't really need super fast storage, you might want to put your operating system on the 32 gigabytes eMMC, and then you can save the SATA ports in the PCIe slot for faster storage. The interesting thing is on the bottom here, you can see there's a couple different layers here that you can unscrew, and I believe you can mount your hard drives that are going to be plugged in here, your SSDs. I think you can mount some SSDs underneath these layers here, which is pretty cool that you can kind of take this apart, and you can mount your some of your SSDs underneath, so you can actually not have them hanging loose off to the side if you don't want. If you want it to make it more permanent, you actually, it looks like you can probably screw it into the bottom here. I didn't look at the instructions, but I think I've seen some pictures that actually show that in action. So it's kind of cool if you want a little more permanent mounting for your SSDs. You can put it underneath there. But otherwise, you can just have them hanging off the side if you're just testing out some stuff. So I decided to unscrew the bottom to see what's in here, and it looked like there was 3 layers there. If you can, I don't know if you can see the lines there, but it's actually 2 layers, because this one has 2 on top sandwiched together, and you can see that little bevel there. And then if I take this one off, it actually exposes the bottom of the board, which is kind of interesting. You'll see that this is your CMOS battery right here. So if you need to replace the battery, it's on the bottom, which is pretty cool if you need to change that out. And another thing that I noticed is right here, there's actually a spot for a CPU fan. It's actually labeled CPU fan. So that's kind of interesting. If you are doing something that for some reason might be generating heat here, you could actually add a CPU fan and maybe just stick it on top here if you find that the passive cooling is adequate enough. The ZimaBoard comes pre-installed with CasaOS, so that's something that you could try if you want, and they give you instructions. I read the instruction booklet. They give you the default username and password for that. So if you want to use CasaOS, especially like an easy OS to get started with, maybe some basic home lab stuff, which is nice. I've seen other YouTubers and other people review that OS and kind of check it out. I'm actually not going to look at it in this because you can find other resources on that. So I'm hoping I can do some things that are maybe hopefully unique, that will be different than some of the other reviews that you've seen out there. So I want to see what we can do with this device, trying and just playing around with it. So that's the fun part about having a device like this, where you have all these different interfaces. You can just experiment with it and see what happens. So what I actually am going to do, I actually installed a 10 gigabit NIC on my ZimaBoard because in the slot. So I actually took the front plate off of it, because you can't leave the front plate on the PCIe cards because it'll overlap your other ports. And actually I couldn't get it even plugged into the slot because the front of the ZimaBoard is just a little bit too long where you can't stick that plate over top the front. They probably designed it just the right length on purpose to make you take that plate off, front plate off of your PCIe card, because it just gets in the way of all the ports and stuff that's on the front of your ZimaBoard. But anyway, so I actually am curious if a PCIe 2.0 by 4 slot can actually support 10 gigabit, because in theory, PCIe 2.0 by 4 is 2 gigabytes per second, and a single gigabit connection, since it's gigabits and not gigabytes, is actually 1.25 gigabytes. So it's actually below the 2 gigabyte theoretical max of PCIe 2.0 by 4. So since we're below the maximum, in theory, even with some overhead of the PCIe throughput bandwidth, the bus that we have, it should be able to get 10 gigabits in theory. So what we're going to actually do is I'm actually going to connect this to this TrueNAS box on this right-hand terminal. So I'm going to run an iPerf test and see how it does with my TrueNAS box. We'll see here if we get full 10 gigabit or not. Actually, I'm using MTU of 9000, which is jumbo frame, so I enable that on all the systems that's on that network. This is actually my storage backend network. So as you can see, I'm getting 9.88 gigabits per second, so that's actually pretty close to theoretical max. So this is a slower CPU, but it's able to transmit 10 gigabits no problem. If you had a dual 10 gig interface, you will not have enough bandwidth, because you'll be going at least 2.5 gigabytes per second on a 2 gigabyte bus. So dual 10 gigabits, you'll end up getting slower throughput, but actually on a single 10 gig interface, you can actually get full throughput, which is very cool. Now, another thing I wanted to try is the opposite direction. One thing I noticed that was interesting about going the opposite direction, sending data to the ZimaBoard, is I actually couldn't get the full 10 gig until I played around with it. So what I'm actually going to do now is run the command with a -R in it, which actually means it's going to transmit from my TrueNAS box or my other system to this system. So it's called reverse mode and for iPerf, which is pretty cool because I don't actually have to go in and switch, this to be a server and then go over to my TrueNAS box and then type a command in over there. This makes it a little bit easier when you don't have to log into their system. If you have an iPerf server running, you can just transmit it. Notice when I do the incoming, it'll kind of burst a little bit extra on the first like 10 seconds or so, but it kind of levels off. It's leveling off between 5 and 6 gigabits. So it's kind of interesting to me when I'm receiving data, it's actually not getting a full 10 gigabits. And one thing that I just realized is if you look at the CPU usage up here, this is a 4-core system. It's actually looks like it's maxing out 1 core because you're hitting 25, plus a little bit extra percent. So you actually looks like you're maxing out 1 core. So then I decided to do 4 streams to see if it actually will help max out the 10 gig throughput on this device. Notice it's using a little more CPU, it looks like, closer to 50%, so maybe it's saturating out 2 cores now. But it looks like that the throughput might be slightly better, or it's hard to tell until you gotta let it level off here, because sometimes the first few seconds kind of bursts. It looks like it's getting 7, we're getting a little bit better maybe than we were getting 5 or 6 gigabits before. All right, so then I decided just to try 2 separate terminal windows from 2 different systems so I can actually get real traffic from 2 physical systems instead of just doing multiple streams from the same system and see what we can get. So if I do try to start them at approximately the same amount of time, notice it's saying 1.1 gigabytes, and I mentioned earlier 1.25 is the theoretical max of 10 gig, and you're not going to get 1.25 gigabytes. So 1.1 is approaching 10 gigs, pretty close. So if you look at this, if you add up these 2 speeds here, we're getting about 9, at least 9 gigabits per second here. If you combine these 2, this throughput between these 2 terminal windows, you can see we're getting probably like 9.2 or 3 gigabits per second, which is pretty good. It's maybe just a little bit slower than our going the other direction, sending data, but we're getting in the 9 gigabit range. So it's actually really good. So we're actually able to get full 10 gigs both directions, but whenever you're sending data to the ZimaBoard, it's going to take probably multiple systems, multiple streams to actually max out the 10 gig throughput. That's actually a pretty cool little experiment. I thought that was neat. Next up, I'm going to do a test on the SSD performance. Gotta type my password in there. So we're going to see how fast the SSD performance is. It should have no problems getting the maximum speed for SSD. As you can see, I'm using an Intel SSD, and usually anything in the 500 to 550 megabytes per second range is pretty good for SSDs. They tend to top out at like 550 or 60 megabytes per second on most SSDs for reading and writing. Writing is usually a little bit slower than reading, but it's actually pretty close. As you can see, when it's Intel, when I'm getting pretty close to 550 megabytes per second, which is pretty good. So as you can see, for the write speed, we're getting a little bit over 500 megabytes per second, which is pretty good. So as you can see, we can get pretty much full SSD bandwidth. So let's stop this and let's try the eMMC storage, just so you can see the performance in that. It's eMMC storage. Typically, performance is a lot worse than SSD. Usually you get about half or like maybe a fourth of the speed of an SSD, but it's still a lot faster and more reliable than a micro SD card, like say in a Raspberry Pi or other computers that have micro SD slots. So it looks like we're getting 160 plus megabytes per second read speed for the eMMC. I've seen some eMMC be a little bit slower than this, and I've seen some be a little bit faster. So this is somewhere kind of in the middle. And for the write speed, we're getting a little bit over 100 megabytes per second. So as you can see, the performance of eMMC is not the greatest, but it's not completely terrible. If you just need it for a base operating system, you don't need a lot of storage, and you don't need a lot of performance because you rather have the performance on a second disk, so you could actually put your faster storage on SSD or NVMe. Next up, I'm going to try TrueNAS. I'm just going to use a single SSD just to test out the storage performance, because I want to see if we can actually saturate that 5 or 6 gigabits, because in theory a single SSD should be able to saturate 5 gigabits or so of the 10 gigabit connection, which is perfect because that's what we found that we could get easily with the ZimaBoard with a single stream. So if you have multiple streams, perhaps you can actually saturate the full 10 gigs, but you might need 2 clients to be able to do that. So what I'm going to do now is look at TrueNAS. I only have 1 drive for storage because I only have 1 extra SATA disk laying around. Let's go ahead and take a look at transferring a file. So I'm going to transfer some files over right now. I want to see the CPU usage. As you can see here on the ZimaBoard, the CPU usage starts spiking, between like 30, 40, up to 50% CPU usage, because with ZFS, it's doing some checksums on the CPU, which for a lower performing CPU like the ZimaBoard, that can actually probably put a heavy, decently heavy load on the CPU. As you can see, it's approaching 40 to 50% at times. So let's go take a look at the reporting here. And as you can see on the CPU, you can see how it's spiking up here. It's actually going beyond 50%. You can see it easier in this graph, because the other one is just updating periodically, but this one you can see it over time, and you can see it kind of can spike up, almost 75% it looks like. And you see the temperatures are rising a little bit on the CPU. It's not terrible, just a little bit. So let's go over to the network performance, because I'm kind of curious about this, because this is where you can see we can get beyond 1 gigabit, but if you look at it and you divide this out, some of this I'm only getting like 160 to 200 some megabytes per second, and which is kind of interesting because that's only about half the speed or less than half the speed of what we know we can get from the performance testing I did earlier on the ZimaBoard. And I'm wondering if it's the CPU's the kind of the bottleneck here and the limitation because of all the ZFS checksums that's happening for the data. So that's one thing to kind of consider. Performance could be better if I had 2 SATA disks in a mirror configuration. So that I haven't got to test that out, but this just kind of gives you a little baseline of like worst case scenario. So I thought this TrueNAS experiment is kind of interesting to see how it works, and it does seem to work okay. If you have just a small storage pool, you might not care that you're getting not much faster than 1 gigabit. Just using it as a small little NAS. You actually could get, you can saturate gigabit easily, but if you put a 2.5 gig card in, you can actually go beyond that. And so you could use it as a little, lightweight NAS. So let's take a look at running OPNsense on the ZimaBoard. Everything was recognized. I even put my 10 gigabit SFP plus interface in there, and it's an Intel based SFP plus interface, and it just was recognized out of the box. So if I go to interfaces and I go to assignments, you'll see that I have the RE0 and RE1, which are the Realtek interfaces, and then IX0, which is the 10 gig Intel interface. So they're all recognized out of the box. I updated OPNsense with the Realtek interfaces, and I did some speed tests on it. But I did all those things with the Realtek interfaces. I haven't noticed any issues, but I haven't really used it long term to find out like if it's going to drop your network connections or have other issues. But just straight out of the box, it seems to work pretty good. I didn't even install the Realtek drivers. Maybe certain Realtek hardware supported a little bit better than others, depending on what's actually in there. I don't know, but it's good to see that it actually at least works decently. And maybe you might end up running into issues. I don't know if IDS IPS has issues with the Realtek drivers more so than other things, depending what you're running on the firewall. But you probably wouldn't want to run those things anyway on this board, just because it's a slower CPU. And you can see just sitting here not really doing much, it potentially spikes up a little bit every now and then, whatever it's doing in the background. So, but this will work perfectly well just for basic routing and firewall purposes. So I'm going to show you a quick iPerf test on my WAN interface. You can see my WAN interface is on my internal network. It's on the 192.168.110.1 network. So I actually have another machine that's on that same network as my WAN interface, which is .119. So I'm actually just going to run speed test on that, show you that you can get full gigabit throughput with it, which is nice. And I'm not really doing any firewall rules or any of that sort of thing. But it does have to traverse the NAT firewall. So it has to do that NAT translation and all that sort of thing. So even with doing that, you can get full gigabit with this CPU.
It looks like it kind of makes the CPU jump a little bit maybe, but it's hard to tell if it's still on some other background processes because it looks like it's hanging in there, pretty low CPU usage. So that's good. It's good to know that you can do this. They always say you can run gigabit off a potato, so this is kind of proof of it because you can run it on a machine even slower than this one. But this machine is still reasonably capable, more than like maybe the older firewall that I used to have. So I'm not really going to do too much with OPNsense on here. I just want to show that it does work and give you the caveat of the Realtek hardware, and show that you can get full gigabit with just the basic out of the box installation. If you start loading it up with IDS IPS, you're going to run into performance issues, of course, potentially even with 1 gigabit interfaces. Keeping those things in mind, you could actually potentially use this as an OPNsense firewall. You might want to use Intel next if you want the best experience. So you might want to get a 4-port gigabit if you only need gigabit speeds, or they make even a 4-port Intel 2.5 gig PCI card as well. I don't know if you'd want a PCI card hanging off the side all the time, but maybe this could be a great backup. So if you just have this device, you just tinker and play around with, and say your main firewall box goes down, you could just pop a PCI card in the ZimaBoard. You could use it as a backup secondary router if your main one goes down, which would be pretty nice because it's potentially cheaper than some of the more expensive mini PCs, but it's kind of close to getting on the low end of maybe even some N100 Intel N100 hardware if you get it off AliExpress. So it's kind of weigh the benefits. So I hope you found that kind of interesting, this little quick look at OPNsense to see how that works. I didn't want to dive too deep into it just because I was trying to multiple things in this video, and I just want to keep the video time constrained, but just show different, 3 different uses for it and how actually it performs. I hope this video helps demonstrate how versatile the ZimaBoard is when you want to test out various software and hardware configurations, because you can just plug in various PCIe cards into the side of this and also attach SATA disks or NVMe adapters and anything you want to kind of play around with on a small little form factor PC, which is pretty cool. Even though I think the ZimaBoard is a very nice little mini PC, there are a few things that I wish on my wish list, if they made a version 2 of this device, that would be really nice to make this even better. Especially now that when they first did this campaign for the ZimaBoard, it was several maybe 3 years ago during the pandemic, and by the time they got it to market and stuff, I feel like the landscape has changed slightly, where 2.5 gig networking is actually taken off really a lot. I've noticed in the last 2 years or so, at least the past year especially. I've seen it just from my Amazon affiliates. I can tell a lot of people are buying 2.5 gig firewalls and adapters and network switches. I can see those types of purchases increasing, and that's one thing that would be nice about this, is if these were 2.5 gig interfaces, at least one, but you might as well do 2. So if this had 2.5 gig networking, that would be nice. It would be nice if the CPU was a little bit stronger, especially now that we got the Alder Lake. You have the N95 and N100 CPUs are out now. Those CPUs would potentially be nice to have in this, because that would give us a huge boost. But I know cooling could be a factor on potentially on some of those types of devices, so you have to kind of watch for those. But some of these newer CPUs have smaller manufacturing processes, so they produce less heat and the same power rating or lower. Potentially 16 gig configuration would be nice. Another thing I'd like to see is, because this has 2 SATA ports on it, I would like to see the adapter that comes with it have just 2 SATA ports on it with a single power cable, because they do sell that as an accessory. It would be nice if it just came with it, just one extra little SATA cable hanging off this, because right out of the box you'll be able to hook 2 drives to it, like SATA drives to it, and have a mirrored configuration, which would be great, because right out of the gate you can actually just have a full-blown little tiny NAS, right? Having a cable like that would be really handy, because now if I bought this device, I would actually need to go and buy that cable, which kind of adds to the cost and the hassle if you didn't realize that, which I didn't know until I got it, that it doesn't come with a cable that has 2 SATA ports on it. So I think that would be a nice thing to add. Another nice thing potentially be is this has a mini display port on the front. I don't know how many people have a mini display port to a full-size display port, or a mini display port to an HDMI cable. I had to buy a mini display to an HDMI because all my stuff's HDMI. I don't have any display port stuff because I actually have some older basic cheap monitors that only do HDMI. So I think at least the mini to full size display port might be handy for people that may not have it. I mean, some people may have it from their laptops and they already have that cable available, but I feel like having a display cable would be nice because I couldn't even install another operating system on this until I bought that cable. I didn't know if it'd come with a cable or not. It'd be kind of a bummer if you bought this and you're not paying attention to all the accessories that come with it, and then you don't have that specialized cable because it's not like an HDMI cable that most people have, most likely. I do know that adding cables and even just adding a little faster interfaces like 2.5 gig, potentially those little things, even though it might add a small cost to each device. And if you multiply it out by all the devices, they lose a lot of money on that. But I think for some of those types of features, some people may be willing to pay a little bit more to have a couple of those nice to have features, because then it becomes more on par with some of the other hardware that you might find with other mini PCs in the same price range, right? That could kind of maybe differentiate a little bit more than it already is. So those are just some little things that would be nice to have. So I hope you guys like this little unboxing and a walkthrough of some things that you can do with this little device. As you can see, it's kind of neat little fun box to play with. This might be something I might just keep on my desk actually to just play around with every now and then with some different things. It's a nice little companion to have on your desk because it's so small and it's silent and doesn't use that much power. So you can just leave it plugged in, play around with it, host some things, try some stuff out. If you needed to load different things and test different things, you can plug stuff in here and do a little quick test run of something. Especially if it doesn't require a lot of CPU, you can just really run whatever you want on this. Host some different things for your own personal use. So in different parts of the world, electricity is more expensive. So, having devices like this that are more energy efficient and tiny and compact, it can be very helpful. So you don't have to run huge servers to do things in your home lab. So until next time, I'll see you guys later.